Video, we're going to go over the logarithmic properties. This is an important lesson because for this unit, what I'm going to do is give you guys an IXL quiz based on the IXL links from this lesson on logarithmic properties. So make sure you do that quiz and make sure you're ready. It's just going to be a small summative, but I want to start introducing those with kind of like the most important lessons each unit. All right, so let's talk about these basic properties of logarithms. The way I kind of view this, right, if you look at this first one here, you have the base of a raised to the 0 power equals 1. So a to the 0 power equals 1. And you guys learned probably in algebra that any base raised to the 0 power is 1. So if you notice a logarithm of any base, right, and the argument is 1, so if this argument right here is 1, it will always be equal to 0. So the log of 1 is always 0. Now the next one, a to the first power is a to the first power is a. So if the base and the argument match, right? So if the base and the argument are the same, then that logarithm will always be equal to 1. All right, so if your base and your argument match, that log is always equal to 1. This one is more of probably what you would think of with the a later property that we'll use. So I'll do it this way first. So a to the power of x equals a to the power of x. All right. But what I usually tell students is you're actually going to move, I'll teach you guys the power property. You're going to move this power to the front of the logarithm to become x times log base a of a. And we just talked about how the log where the base and the argument are the same is the same as 1, right? So that's going to end up being equal to x. All right? Okay. Let's look at the next one. This next one's a little tricky. Let me kind of write something for you to help. So if I write the log base a of x equals the log base a of x. So this is just using a property you learned probably in middle school called the reflexive property, that they are the same. If I were to think of this one as my base and do a to this whole thing as the power is equal to that argument, I would write a raised to the log base a of x equals x, which is where they get, that should be in the subscript, that's where they get this property here, that if you have a big base raised to an exponent where there's a logarithm in that exponent with the same base as the big base, then whatever the argument is your answer. Okay? All right, let's go to the product rule. The product rule that it says if you have a log of any base and your argument, right, so this argument has things connected with multiplication, you can expand that, right? So expand it with 2 logs with the same base, where each argument gets their own log connected by addition. All right, now we're going to start by expanding, but you can also use this property to condense. So if you have 2 logs with the same base connected by addition, you could put them together as 1 log with that same base, and you multiply the arguments. So we'll be doing a lot of like call and response with this, that if you see multiplication, you think addition. If you see addition, you think multiplication. So addition and multiplication are linked. So let's use that to expand a couple here. So I'm going to write this as the log base 3 of 30x, right? That's kind of like my first thing. And then plus log base 3 of 3x plus 4. Right, that's kind of my second argument. Now, let me show you the difference in what we can do from here. Right, this 30 and this x are being connected by multiplication. So I'm going to use the product property to expand that again. But this 3x and this 4 are not connected by multiplication. So that logarithm is going to just stay like it is. So log base 3 of 30 plus log base 3 of x plus log base 3 of 3x plus 4. Okay? Let's try expanding this one. This one's probably as straightforward as you can get. We have a log base b, and 8 times k is my argument. So because 8 and k are connected by multiplication, I can write log base b of 8 plus log base b of k. Okay, let's go to the quotient rule. Quotient rule is very, very, very similar to the product rule. It's just instead of having multiplication and addition, linked up, now we have division, right? Here's division, and subtraction linked up. So the way I think of this is if you have a logarithm, all right, and your argument is a fraction, you can expand that logarithm into two logarithms, and they're connected by subtraction. All right, so you're thinking division with subtraction, subtraction with division. All right, so let's try this one. A lot going on here. What I always tell students is that kind of to go faster, I'll take the long way on this one, but to go faster, if it's in the numerator, it's going to be addition. If it's in denominator when you expand, it's going to use subtraction. So let's do log base 2 of this numerator, which is going to be 15x times x minus 1. Okay, minus log base 2 of the whole thing in this denominator, which is 3x plus 4 times 2 minus x. Okay, now this is important, okay, that even though when you look here, okay, when you look here, they're connected by multiplication, so I'm going to expand them with addition, but you're going to see that it ends up, because they're both in the bottom, you're going to see why it ends up becoming subtraction. So I'm going to split this up, 15x plus the log, I guess I put my base 2, of x minus 1. So that should be familiar from the last product property, minus, all right, and put this in a bracket, log base 2 of 3x plus 4 plus log base 2 of 2 minus x. So the reason that it's in brackets, guys, is because when I expand this, right, yes, I'm using addition, right, they're connected by multiplication, but if you notice, we have a subtraction in front of that whole thing, okay? And you're going to now distribute this negative, right? So this negative right here is going to distribute onto those two logarithms inside the brackets, which, as I kind of mentioned, that if you notice, I'll highlight it, right? If you notice it's in the bottom, it's going to have a subtraction symbol in front of its logarithm, okay? So let's keep finishing this. Log base 2, I'm going to make 15, and then log base 2 of x, I can split that up, plus log base 2 of x minus 1. And now right here, as I said, this stuff was in my denominator, so it's going to have subtraction in front of both of them. All right, and that's it. I know that's a lot. You can, as you get better at this and start to see the patterns, feel free to kind of do more steps in your head. And it's up to you on how much you want to show. All right, so let's see if I can do this one for you, going like kind of taking a few steps at the same time. Notice what's in the top, right? So in the top, you've got 7x squared. Let's put that in parentheses. 7x squared plus 21x. And then in the bottom, so watch this, minus the log base 3 of 7x minus the log base 3 of x minus 1 minus the log base 3 of x minus 2. So as I said, I kind of did a couple steps there, in my head, where if it's in the denominator, right, if it's in the denominator, when I separate it into its own logs, you'll notice that all three of those had subtraction in front of them because they got to go in the bottom. All right. Now, what I notice is this argument here can be factored as 7x times x plus 3. So I'm going to actually expand that to be the log base 3 of 7x plus the log base 3 of x plus 3. And then minus log base 3 of 7x minus log base 3 of x minus 1 minus the log base 3 of x minus 2. Okay, now I got a couple things that I can split up, but if you look at this right now, the way I'm looking at it is if you wanted to expand the 7x's, but what I also notice, if you take a moment, is this says the log base 3 of 7x, and that says minus the log base 3 of 7x. That's just going to make 0. So I'm not, sorry about that. I am not going to expand that when it makes 0. So I'm just going to write down my answer, which is log base 3 of x plus 3 minus log base 3 of x minus 1, and then minus log base 3 of x minus 2. All right, so that is expanding that logarithm. Okay, let's talk about the power rule. I kind of mentioned this at the beginning of the lesson. Power rule just means that if you have some power, right, like this 2, that is on the argument that the argument's being raised to, you can move it to the front, all right? So I'm not going to write it like that. You're going to write it as 2 times the log base b of x, okay? So you'll notice up here, right, the n moves to the front and multiplies by that logarithm. So this is one of those where it doesn't seem like it's that big a deal, but it's probably the most important just because of what it will allow us to do in the next lesson. So we have log base 2 of x to the 5th power. So this is going to be 5 times log base 2 of x. Okay, so it's going to move to the front. Same with this one. The 2 is going to move to the front. So we're going to have 2 times the natural log of x. Now this is our first time we're seeing the natural log. The natural log just means it's a logarithm with the base of e, right? That number e has come up a few times so far in this unit, right? That e is approximately 2.7183. All right, so if you have ln, that means the natural logarithm with a base of e. So if you wanted to write that e there, you could, but no one ever does because if it is ln for natural log, it is a base of e. Okay, let's try this one. It says use the power rule. So I'm going to rewrite this as log base 3 of 5 squared, because 5 squared is 25. Then move that 2 in front to get the log base 3 of 5. All right, this one is a little interesting. So I have the natural log of, watch how I write this, x to the negative 2nd power, right? Because x in the negative 2nd power is the same as 1 over x squared. Move it to the front now, and you get negative 2 times the natural log of x. All right, now this one is just saying to go the other way, saying to move this 2 and move it to be a power up there. So log base 3 of 4 squared, and 4 squared is going to be log base 3 of 16. All right, so you can go both directions. Okay, let's do some problems on only expanding, and then after we finish that, we'll do problems on only condensing, so you can see kind of the work you'll have to do. All right, so using the properties that we just gone over, let's expand this natural log. So the way that I always think of it is if it's in the top, right, it's going to get a log with addition in front of it. So the natural log of x to the 4th power plus the natural log of y. And if it's in the bottom, it's going to get subtraction in front of it. So minus the natural log of 7. Okay, now this is almost done, but I do see a power that I can move to the front to make this 4 times the natural log of x plus the natural log of y minus the natural log of 7. Okay, let's try this one. Same idea, right? I see stuff in the top that's going to get logarithms with addition, and then I see z to the 4th power in the denominator, so minus the log of z to the 4th power. Move all those powers to the front, and then you'll be done. All right, and this is really good practice, as I said, for that IXL quiz that you'll have to do with these properties. Okay, I'm going to actually first rewrite this as the log of x to the 1/2 power, right? When you see the square root of something, you can always rewrite that to be whatever that something is raised to the 1/2 power. So now if I move that 1/2 in front, I get 1/2 times the log of x. So that's it, I'm done there. Kind of same idea here, the natural log. If I rewrite this cube root of x squared as a rational exponent, right? It's going to be x raised to the 2/3 power. Remember, think whatever is the index is the denominator. So if I move that 2/3 in front, I get 2/3 times the natural log of x. All right, a lot going on here with this one, but what I would always tell students is if it's in the top, make sure it has addition. If it's in the bottom, make sure it's with subtraction. So log base 6 of 64x cubed plus log base 6 of 4x plus 1, and then minus log base 6 of 2x minus 1. Okay, let's split up the 64 and the x cubed. So I can write that as log base 6. So let me just say one thing before I kind of get too far down this road. What I'll see students do is they'll move that 3 in front, but you can't do that yet because that 3 that on that for the x cubed is only with the x. So it would be incorrect now to use the power rule. So you want to first split it up to write log base 6 of 64 plus log base 6 of x cubed. And then in the last step, we'll go ahead and move that 3 in front now that the 64 has its own logarithm. So that's just kind of a thing to remember as you're doing this. Just be careful if it's not, if that power is not raised for all the stuff in the argument, you can't use the power rule. All right, so last step would be to move the 3 to be in front. So 3 times the log base 6 of x. And then just copy everything else down. So what I noticed when I was in high school learning how to do all this stuff is, there's just a lot of copying that goes on, and not like in a cheating sense, but just in like you just got to keep copying the next line. So when you start to get a feel for this, feel free. I'm encouraging you to show less work. Obviously if you get anything wrong, let's go back to showing the work. But you're going to see that it kind of saves your hand because you're writing so much if you skip a few steps. Okay, let's do this. The first thing I notice is that my numerator is all in a radical, all right? And that's a square root radical. So I'm going to write this as the natural log of x minus 1 times 2x plus 1. That thing is squared. And then all raised to the 1/2 power, okay? And then minus the natural log of x squared minus 9. Remember, minus because it's in the bottom. So I'm going to use the power property. Remember, the whole thing, that's what I said, is different than the previous problem. The whole entire thing is being raised to that 1/2 power, so I can move it in front. All right, of x minus 1 times 2x plus 1 squared minus, and I actually noticed that this can be factored as x minus 3 and x plus 3. Okay? Now, when I expand that first logarithm, all right, that 1/2 is going to be in front of both of these things. So natural log of x minus 1 plus the natural log of 2x plus 1 squared minus, I'm going to expand this, the natural log of x minus 3 minus the natural log of x plus 3. Again, that's me skipping a step, right? I know when you expand x minus 3 and x plus 3, you should use addition, but because of this subtraction in front, it's going to be subtracting from both, right? So the idea is if it comes from the denominator, it's going to have a negative in front of that logarithm. Okay, now if I move this power to the front, actually let's do this first. Let's distribute the 1/2, all right? And then you'll notice there's just a lot of copying going on. Okay, and this last step is I see a power on this 2x plus 1, right, raised to the second power. So if I move that in front, it's going to multiply. Well, there's already 1/2 there. So 1/2 times 2 is 1. So actually that logarithm, when I finish writing it, is not going to have a coefficient. Oh, I forgot it's logarithm. My bad, let me do this real quick. So 1/2 natural log. There we go. Can't forget the logs. So the natural log of 2x plus 1. So no more power. And then just copy down these last natural logs. All right, so that's a combination of all that. So hopefully you get some good practice there on expanding. So now we're going to go the other way. We've got lots of different logs, 2, 3, 4, however many logs. And we're going to use our properties to write them as one logarithm. All right, so again, this can be as many or as few steps as you want. I usually try to do it in one step. There might be some simplifying that has to happen. Like in this one, I know I'm going to have a fraction. And on top, I've got 5, because it's a positive in front, times 8. And then in the bottom, I have 2, right? So that argument, because that subtraction, goes in the bottom. All right, so this is going to be the log base 3 of, let's see, 40 divided by 2 is 20. Okay, let's try this one. Same idea. I'm going to write my fraction bar. I've got 3 on top, 4 on the bottom, times 5, and then times 6 on the bottom. Remember, don't forget if it has subtraction, it goes in the bottom. This is going to reduce to 1/2. So I have the log of 5/8. Okay, let's see how you feel about this. So on this one, when you're condensing, right, if you've got powers that are in front, or I should say coefficients in front, you want to move them to the back to be powers. So these numbers, I'm going to move to the back to be powers. And when you do that, it's going to end up giving you, I'll kind of write it again up here, log base 2 of x squared plus log base 2 of x minus 1 to the 1/2 power, and then minus, let me actually start over so I don't lose my space here, log base 2 of x squared plus log base 2 of x minus 1 to the 1/2 power, and then minus log base 2 of x plus 3. Now watch this, that's squared, but then all of that raised to the 3rd power. Okay? So when I write my answer, log base 2, I've got my fraction. All right, so in the top is going to be x squared. All right, also in the top is going to be x minus 1 raised to the 1/2 power. I know I've been saying this many times now in these lessons if you've been watching these videos. Anything raised to the 1/2 power is the same as the square roots. So I'm going to put the square root of x minus 1 up top. Okay, and then this right here is a power to a power, and that's where you multiply to get 6. So in the bottom, it's going to be x plus 3 to the 6th power. All right, maybe wondering why I put it in the bottom, right? It has subtraction, so that's why it all goes in. That goes at the bottom. All right, so that's it for that problem. Let's try this one. Again, I've got powers that I want to move to the back. All right, this last one's going to be the trickiest. Let's see if we can write the answer. I think we should be able to figure this out after our work so far. So in the top, you've got x squared, right? You're moving that 2 to the back to make it x squared. In the bottom, you're going to have x plus 5 raised to the 4th power, right? See that subtraction's in front of it. And then watch this. You've got the radical of 3x plus 5. You may be wondering, Mr. Frederick, why are you writing a radical? Well, as I mentioned earlier, when you raise something to the 1/2 power, that's the square root. This is going to be 3x plus 5 raised to the 1 over x power. So instead of having the square root, we actually have something called the x root. So I don't actually know what x is, but whatever it is going to end up being my x root. So if I plug in 2 here, it's going to be a square root. All right, so that's it for this one. Probably the trickiest so far. Move some powers. X to the 0.5 power is just going to be to the 1/2 power, right? 0.5 is 1/2. Another power as well. So let's write down our 1 logarithm. In the top, I'm going to have 5. In the top, I'm going to have the square root of x because of that x to the 1/2 power. And then in the bottom, I'm going to have 7x minus 1. And then also in the top, I'm going to have x minus 1 cubed. Okay, so that's it for this one. One more, and then we'll be finished. All right, so the very last one. The very last one, we've got these powers in front. Actually, you know what? I see that this 4 is not just in front of the first log. It looks like the whole thing's got parentheses. See these parentheses here? So I'm going to actually distribute that first to get 4 times 3, which is 12, times the log of x plus 4 times the log of x plus 5 minus 4 times the log of 2x plus 3. Now I'm thinking let's move all of these coefficients into the back to be powers. And so I'll write down my answer as log In the numerator, I've got x to the 12th power. I've got x plus 5, x plus 5 to the 4th power. And then in the denominator, right, that minus has 2x plus 3 to the 4th power. So this is the last one. All right, so there's 3 links to do for IXL to practice, and then don't forget to try the IXL quiz based on these links. Good luck.